CC minus CG. So here is minus 5 minus 2, 0, 0. Okay, so you will find the CC minus CG that greater than equal to 0 to find the simplex method. So you can continue the step by step like before, right? Okay. For make you more understand, you can try the question that I give, and you can find it by the simplex method. Any question?
Not yet.
Okay. So that's all for today, guys. Thank you so much for your listening and participation. And wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you.
See you later.
Guys, how about we work together for this task?
I absolutely agree with that. Yeah, me too. I think I will be confused if I work alone.
Guys, I've done the assignment given by Miss Daniela. Let me explain first. So guys, first we must know that x1 is for 4 color and x2 is for 2 color. So from the question, we must write the math model first. At first, we choose to know about the maximum value of C. From the question, I got 24,000 x1 plus 10,000 x2. So and then we must find the constraint. And here I got the 3 constraints from the question. First constraint is 16x1 plus 8x2 less than equal to 52. So why I cut 52 here? And the question right is 1000 or 1000. So because the MC produce at least 2 in a week, we must multiply 16 and x by 2. So we got the value 16 times 2 plus x times 2 equal to 48. So we must subtract the value 100 with the value of this. So we got 52 here. Then we repeat the same step with the second constraint and the third constraint. We must write the new math model here. So from the question also, we got the maximum value of Z is same like before, 24,000 x1 plus 10,000 x2 plus 0 s1 plus 0 s2 plus 0 s3 because we have 3 constraints. And the first constraint is 16x1 plus 8x2 plus 0 s1. And we must reply the step with same step until the third constraint. And here we must note that x1, x2, s1, s2, s3 greater than equal to 0. So don't forget to write s1, s2, and s3, guys. And then we must input the value from our new math model here to table here. Like this. Q for 52, 76, and 18, and so on. So from here we must find the ZG minus GG, and here we got minus 24,000 minus 10,000 0, 0, 0. So how I find the CG minus CG value here? I multiply the h of CB with h of x1. After that, I sum all of them and I subtract with the value here. And here I write 24,000, and then I get minus 24,000. I repeat the same step with the rest of the table. So I have minus 24,000 minus 10,000 0, 0, 0. And then we move here. We must find the k column by divided the h of q value with h of x1 value. So here I got 52 divided with 16 and so on. So I choose the positive minimum value of this to find the k column. I got this as the positive minimum value 18 over 8 as k column. So we can find the 8 as a k element. So I will continue to the next step, guys. So I find 8 as a k row before, and 8 is in third row. So we choose third row as a k row. So we must divide it all of the value in third row with the k element, which is 8. So I find the k row is 18 over 8, 1, 3 over 8, 0, 0, and 1 over 8. After that, I must find the another k row, which is first row and the second row. Find the formula q minus another element in k row, which is in row 1. Our first row is 16, multiply with the value of k row before. So I have 16 here as the final value of row 1, and we must continue the another step with the same formula before. So here we have the another k row of first row and the second row. After that, we must compute all of the value in row 1, row 2, and row 3 in new table. So guys, after I do all of the steps, I can find the final table. So, because there is no negative value of CT minus CT, I can find and I can conclude that the program is optimal. So I write here as all of the values CT minus CT greater than equal to 0, so the program is optimum. And before I have the maximum value of Z, which is 24,000 x1 plus 10,000 x2. And here from the final table, I can find the value of x1 equal to 0 and x2 equal to 6. After that, we substitute the value of x1 and x2 to the maximum value of z. So I have 24,000 multiplied with 0 plus 10,000 multiplied by 6, and I have the final value for maximum value of z is 60,000. Do you guys have opinion about this?
That's really cool, no? I haven't finished this yet, but to be honest, I have some concern what you explained. I mean, like, there's something wrong, but give me time to work on it first.
Yeah, no. I also want to try to do it first.
Okay guys, let me explain mine. I actually have very different constraints with Novita, since in the question said that DMC also produced 2 units, at least 2 units per week. I think it must be a constraint also. So here I have 5 constraints. The first constraint is about a shortage of steel rollers, and then the second is gear cutting capacity, and then the third we have roller polishing capacity, and then the fourth and the fifth are from the question that say the MC produce at least 2 units per week. So at least means that we have to write it rather than Apple. Now, since we have 5 constraints but not in the standard form, I think we have to use dummy variable. In the new math model, the first 3 constraints I use S1, S2, S3 like a common constraint, and then the fifth and the fourth I use dummy variable here. We have to write with minus S4 plus, this is the dummy variable, guys, with plus XA, and then the fifth constraint use XP. Here the dummy variable. So the objective function, it must be like this: 24,000 x1 plus 10,000 x2 plus 0 s1 plus 0 s2, 0 s3, also plus 0 s4 plus 0 s5 minus mxa minus mxp. Here the dummy variable. It actually same step with novita before, but in the dummy variable I add the column of XA and then XB. Also in the CP we write it with minus M and minus M since the value of the variable of dummy variable is minus M. And then the next step is the same. We have to find the CG min CG. I found the minimum value of CG minus CG here. So in the column X1, and then the row column, the K row is here, since it's minimum positive value. So the K row, it must be the fourth row here. And the next step, we have the same step like the common way. So guys, here after I calculate the K row transformation and another row transformation, I found the first row, this number, and then this is the fourth row. This is the first row, this is the second row, the third row, and the fifth row. And then we input them to the new table. Not for you, if the dummy variable on the column VTB is changed by x1,
So means that XA is out of the program and is still written in the table. But however, for the next calculation, we don't need to count XA anymore.
and then I found the ZG min minus CG here on the column X2, and then find the K row on the last row. So we have the K element here, and it's the same step. So guys, after all the calculation of the K row transformation, I input to this last table. Since the CG minus CG, there is no negative here. There's no, this is all positive, so this program is optimum. And then I found the X1 is 2, and then the X2 is 8. And then the setmarks I found 24,000 times 2 plus 10,000 times 8. And then I found 100 to 128,000. So this is mine. How about you, Tasha?
Okay, guys, I drew my work like this. So from that question, you must do make my model first. Okay, so the math model is same like before, that is maximum C equal 24,000 x1 plus 10,000 x2, and then it's up to 16 x1 plus 8 x2 less than equal 100, and then 30 x1 plus 12 x2 less than equal 160, and then 8 x1 plus 3 x2 is less than equal 40. And the fourth and the fifth constraints, actually it seems like they have, but I changed the sign of the fourth and the fifth side with multiple by minutes. So we got the fourth and the fifth constraint, that is minus x1 less than equal minus 2, and then minus x2 less than equal minus 2. Next, we must to change the math model to new math model, that is maximum z equal 24,000 x1 plus 10,000 x2 plus 0 s1 plus 0 s2 plus 0 s3 plus 0 s4 plus 0 s5. We must do sub to 16 x1 plus 8 x2 plus 0 s1 equal 100, and so on. Okay, so we must to input all of this value in this table. Okay, so we have first table. I've done input all of this value, and the next step is we must to find the CT minus CT value from the column of CB multiplied by column of x1, and then add all of them and minus 24,000, and we got minus 2 minus 24,000, and so on. Okay, and then we must to choose where is the minimum value of CT minus CT, that is minus 24,000. And then next step, that is we must find the assignment value, that is from the value of Q over the value of the K column, that is x1, so 100 over 16, 160 over 30, and so on. And I got 2 as the positive minimum value in assignment. And then from the K column and the K row, we get the K element, that is minus 1. And minus 1 in row 4 or R4. So R4 will be the K row of this table. So we got the K row R4, that is 2, 1, 0, 0, 0, 0, minus 1, 0, and another of R4, that is R1, R2, R3, R5, and we got 68, 0, 8, and so on. And then the next step, I will continue with the new table. Okay, guys, and I got the final table of this math model of that questions. So I got fifth table in here, and as you can see, the value of CT minus CT is positive. All the value is positive, and we can say that all of CT minus CT is greater than or equal 0, and this is the optimum program. And then we can find the value of the maximum z. From x1 point x2, we got x1 is 2 and x2 is 8. And then we get the exact max, that is 2 times the value of x1, that is 24,000, and the value of x2, that is 8, that times with the value of x2, that is 10,000. So we got 128,000. So the value of maximum z is same like me, but different way like me. Okay, guys. So it's my explanation about my task.
Wait, guys. I'm still confused why you guys have the same answer, but not me.
I know, right? Well, the answers are so different. Don't we just consult Mrs. Daniel?
Yes, I think that's a good idea. So we can understand it better.
Yes.
Okay. Let's go.
Assalamualaikum. Hello, Miss Daniel. We are from ICMAP 8023. Would like to ask you about the problem Miss Daniel gave us last week.
Okay, you can sit down here and let me check your work.
Okay.
Yes, let me check what you said. Okay, so what's the problem, guys?
Okay, Miss, so we have done to do the task, but our answers are all different. Can you please correct all of our work?
Okay. Let me check it. Here, 1, 6, 1. Okay. I think that's very complex. So I think I should do explain about the mathematical first. And then see the picture on the television. Yes, is it the question?
Yes.
Okay, guys, I know that you found a problem with this questions. So firstly, I think I want to explain about how to find the mathematical grade, because the mathematical is the fundamental things that you should find it correctly before you're going to solve the problem with SIMPLEX method. So from the question said that the MC doesn't want to raise prices. It means that we should find SIMPLEX with SIMPLEX method. So how can we find the SIMPLEX? Okay, firstly we should make the mathematical. And here, from the question, it said that TFC or Tetralider Machine Company makes two types of printing processes. So it will be two variables here. The two variables that we will use is x1 and x2, and you can use x and y, but now we will use x1 and x2. x1 as 4 color and x2 as 2 colors. So we will note it first. x1 equal to 4 color and x2 equal to 2 color. Okay. So for SIMPLEX, actually we should know about the coefficient of x1 and x2 from this sentence. At current prices, TMC will earn a profit of TM 24,000 on each 4-color press made and TM 10,000 on each 2-color press made. So here 24,000 is the coefficient for x1 and 10,000 is the coefficient of x2. After we find SIMPLEX, find the constraint from the question. The constraint is for shortage of steel rollers that I highlighted with 2 colors, and the second one is clear cutting, and the third one for the roller polishing capacity. So we will find the first constraint sequence. The first constraint sequence will be a shortage of steel rollers, or we can see it on the blue color here. So here, how can we find the coefficient for x1 and x2, which is for the first constraint sequence? So we can see here, for each 4-color press requires 16 rollers. I will read again. Each 4-color press requires 16 rollers. So it will be the coefficient of x1. And each 2-color press requires 8 rollers. It will be the coefficient of x2. Because what? Because here there is the word say that 2-color press. Okay. Do you understand? Okay, good guys. So we will write here as 16 x1 plus 8 x2. So because if we want to looking for the SIMPLEX, we will use the less than equal to. Now, how can we find a less than equal to whatever? Now, we can find it here. The sentence here. TMC is able to buy 100 rollers. Remember, we still discuss about the first constraint sequence. So it will be 100. Okay. So here, 100. So it's same, the way it's same, step by step is same with the first constraint sequence here. We will find the second constraint. It will be here through cutting. So 30 for the coefficient x1 and I'm sorry guys. Okay, 30 for 30x1 and 12x2. So here 30x1 plus 12x2 and less than or equal to, before is 100, so the second one is 160. And the third constraint sequence will be placing time here and 8x1 plus 3x2. 8x1 plus 3x2 less than or equal to 40. Okay. So, guys, you should read it carefully because here GMC also wants to produce at least 2 units of each press each week. So we will have 2 constraints again that will be like this: S1 greater than or equal to 2 and S2 greater than or equal to 2. So here is the math model that we find. Okay, after we find the right math model, let us check it with POM-KM. Have you guys find it with POM-KM?
No,
Not yet?
Not yet.
Okay, so we will see it or we check it with POM-KM. Yes, yes. And we will find the answer is 128,000. And yes. So here is the answer. Okay, let me check the answer one by one. So the first work, so here is Novita's work, right? Right, okay. So here, the math module is still not right. Because if it's not, here, yeah, that here, x1 and x2 are more than equal to 2, then don't eliminate it and change other sequence. Here it will be less than or equal to 100, right? So you cannot just like change it with less than or equal to 52 and you disappearing the x1 and x2. Okay, so because your math model is still not right, of course the answer or the set max is not right. Okay, so the next one will be my works and Tasha works, right?
Yes.
For my works, the math model is right. Yes, like before, I have explained about the math model, right math model here. You use dummy variable, me? Yes, okay. So the third one will be Tasha's work. Oh, here is another way. But here, for Tasha's and May's work, it has the same answer like the POM-KM. So, here Tasha just use the usual simplex method. Okay, so the difference is from the the constraint, right? Okay, if May, the constraint is like my math model before that I have explained to you, and for Tasha, so she use like just change the inequality before for less than equal, so she changed it with x with minus x that less than minus 2. From before is x greater than equal to 2. So guys, I can conclude that May and Tasha works is the right answer, but here is 2 ways to find the answer or to find the simplex method. The first one is by using the time dummy variable, and the second one is for using the usual simplex method. And that's all.
Yes, miss.
Okay.
Miss, thank you for the explanation, Miss Stella. So can we go first?
Yes. Thank you.
Thank you.
Thank you, Min. You're welcome. Yes. Okay. Take care, guys.
Is this camera still on or not? Huh?
Thank you guys. Don't forget to like, comment, and subscribe.
Well done. Dikemas.
Cakep.
Next time, be careful ya, guys.
Hah?